In this video, I'll show some progress I made on Quadrant. Quadrant is a programming environment that allows you to develop temporal scenarios for live shows and art installations. In the previous video, I gave an overview of the system, its goals, and its main temporal features. So if you haven't watched it yet, you'll find a link in the description below. Here, I'll talk about a few aspects of the Quadrant programming language. But first, credit to where credit's due. If you know the Odin programming language, you'll probably recognize that I took some inspiration from it. And of course, Quadrant and Odin look very different in terms of syntax, the kind of platform they target, and their underlying goals. But I really like the general design stance of Odin, and I think Ginger Bill, who is Odin's creator, managed to strike a very good balance between human factor considerations and technical considerations, which helps make Odin simple and pleasant to use, yet powerful and productive. So I've certainly been influenced by its design. The first thing I wanted to show is typed Variadic Procedures. So let's say we want to define a sum function that will take a number of arguments. I can use the varg parameter specifier, which itself takes a type, and I will return the result as an integer. Let's declare a variable to hold the result. And from inside that procedure, the variable argument is treated like a slice. So I can look through the slice. I can take the length of the slice here. And I can accumulate the argument in the result. Let's return that. And now I can sum a number of arguments. The next feature is polymorphic procedures. For instance, I want to define a square function that will multiply its arguments with itself, but I want to be able to use it with different number types. So I can use a polymorphic type specifier using the $sign here, and then I can use that as a type specifier in the rest of the definition. And now I can call my square function with an int, or for example, with a floating point number. I can also use explicit polymorphism, where I will pass a type specifier as an argument to a procedure. So let's say I want a procedure that takes a type and a count and allocates and initializes a slice of that type. I will call that enumerate. And I can use polymorphic identifier as a parameter name and the type ID keyword as a type specifier. Let's add a count parameter, and I can now use the polymorphic parameter name as a type. So I can return a slice of that type. Let's allocate that slice using the default allocator. And now I can initialize the slice. And I will initialize the slice with the index I. Let me return that slice. Now let's declare a variable, which will be a slice of type, let's say, f32. And I will allocate and initialize that slice using my enumerate procedure and passing f32 as the type and 5 as the count. Let's print some elements of that slice. And I can then free the slice. Looks good. Another important milestone is that you can now save and load files. And you can actually open multiple files in the editor. And you can see in the status bar here which file is being edited, and you can switch which file you want to edit using the drop-down menu. And you can also use keyboard shortcuts to cycle through the files. You can also select which file is used as a starting point to build and run the Quadrant program here. So for example, if I select my test format program, I can now run this to print some formatted strings. And each file is actually a module which is parsed and type-checked within its own namespace. So you can import modules into other modules using that format directive. And you can then refer to symbols defined in that module by prefixing their identifiers with the module's name. So for example, here I can use the print procedure that is defined in the format module. Now let's open the Nets module, which deals with UDP and TCP connections. This module essentially binds C functions and allows them to be called from Quadrant code. This is done with this foreign block here that requests a dynamic library to be loaded into the Quadrant environment, and it then declares the procedures that need to be imported from that library. And you can then call them as you would for a regular Quadrant procedure. So the idea now is to build a small number of core modules that will allow Quadrant to speak to the outside world, so that we can receive data from keyboards, sensors, mixing desks, and so on, and also send commands to lighting and video or sound equipment. For now, I'm working on a net module that handles TCP and UDP sockets, as well as an OSC modules that allows composing and parsing OSC messages, and also a number of utility modules that provides helpers like memory allocators, formatted printing, or string operations. In the next video, I will demo how you can use the net module and the OSC modules to communicate with a MaxMSP patch. Until then, take care, bye.